All right, so now we're going to look at number 15. In this problem, we've got Jordan. He's hitting a tennis ball, and he's hitting it straight up from the edge of a building. The building is not a very tall building at 4.8 meters. The picture here where I'm showing all these wonderful windows here, I don't know, it's a building for midgets or something. And anyway, it's 4.8 meters, and this ball's going to be in the air for 4.95 seconds, which is a very long time for a ball to be hit in the air. If you think about our tennis ball activity, that's a long time to have the ball in the air. In any case, I'm asking, what is the initial velocity just as it leaves? I'm asking what is its final velocity right before it hits the ground, and then I'm asking how high it goes. And here we can see I've decided to start off by having the initial be at the top of the building and the final to be at the very bottom, which I think is a good idea because those are the information we're given. We're given this 4.95 seconds, which is that total time. And that way I'll be able to use that 4.95 seconds. Let's take a look what happens. So my initial velocity I don't know. My final velocity I don't know. But sure enough, we get three things that we know, which is all we need, right, in order to get all five of them. So our acceleration is negative, of course, being downward, 10 meters per second squared. Our time in the air was given, 4.95 seconds. And be very careful with our displacement here. It's easy to forget that this needs to be a negative. That negative displacement is because it ends lower from where it started. We started up here, it ended down here, so that displacement needs to be -4. So now let's look at our equations and decide which equation we want to use with this given information to be able to start solving for the two that we don't know. And it looks like a nice one to use is the last one here, where the displacement is equal to VIT plus 1/2 AT squared. That's because VI is all by itself here. You'll notice in the first two equations, we have VI and VF, and we don't know either of them. So here we're ready to plug and chug. It's quite simple. We go ahead, our delta x is -4.8. We go ahead and we put in our time of 4.95 seconds. And in this one, we know everything. We have our acceleration being -10. We have our time being 4.95. I'd like to point out also that in my chart over here, I was careful to put the units. And by stating the units here, that's nice. It allows me to get sloppy. I don't have to put the units here because I've shown what the units are already in the problem. Be careful doing your algebra. This ends up being a negative number. This is a negative number. When you solve for VIT, take your time, check. You should get 23.8 meters per second if you do a good job with that. So now we know the initial velocity just as it's leaving. Let's attack for the final velocity now. And that's easy to do now with this equation. VF equals VI plus AT. Plug in the information that we now know, the 23.8 and the -10. And our total time, again, is 4.95. We get our final velocity, which is going down. Sweet. What's our last piece of information we need is how high it goes. But you'll notice we'll never learn that when we chose this to be our initial and this to be our final. We need an x at the top in order to figure out how high it went. So that means we're going to change where our final is and put it up here. So having the initial here and our final up at the top, we've changed the problem. We're starting over. But now we'll be able to know the displacement in this case will be how high the ball goes from the top of the building. But we're starting over. That means we need to make our chart again. So we make our chart, make sure we put our units, we're careful, and hopefully we know three things. Let's take a look. Because we already solved for the initial velocity back here, sure enough, we know the initial velocity still. So it has initial velocity 23.8, final velocity 0 because it turns around at the top there. Our acceleration is -10. And with these three pieces of information, we'll be able to get this. We don't need to know the time because I never ask what's the time on the way up. So we should look for an equation that has delta x in it, but it doesn't have time in it. That'll save us some time. Sure enough, if we use VF squared equals VI squared plus 2AD, we sure enough don't have time in it, and we can solve for delta x. Careful with your positives and negatives, and you should get 28.3 meters. That's how we do number 15. I hope that helped you out. Good luck, and see me if you have any further problems. Thanks.